Hello and welcome to this new tutorial. In this tutorial, we will see how we can perform object detection using Mask R-CNN in Emgu CV from videos. This video is almost same as the previous tutorial number 79, only we are going to apply the object detection on videos. In that tutorial, we applied on images. So you must check the previous video and then you can follow along to this new tutorial. In last video we saw that we need three things: the pre-trained model, which I basically downloaded from the Learn Open CV. I will provide the link in the description of this video. And we needed the architecture of the network, and which is available in the Open CV's GitHub repository, and I will also provide this link in the description. And since we are classifying different objects, so I need the Coco labels names, and which basically we can obtain from this GitHub repository of or this friend. So all these three things we need to apply Mask R-CNN, which I have already downloaded and placed them in a folder over here. So you can download them, input in any location, and then you can use this path. So this project is already configured since I have been using it for my tutorials. If you don't know how to configure and set up Emgu CV in Windows Forms, you can check my previous videos. So let me go and add a new menu item, and let me call it object detection Mask R-CNN video, and we can double click on that and then write a try catch block so that we shouldn't have any exception, and in case if there is any exception we can show it in a message. What was the message? So ex.message. And since we need to read a video, but here we have only a menu item for reading the images, so maybe we can rename it like open or read image, and I need to add one more for read video. So we will read a video, double click on this read video. I will also use try catch, and if we get an exception we can show that exception to the user ex.message. What I will do here is first I need to declare a few things on top of this class. The first thing that I need is to create a video capture object. Video capture, we can call it video capture or just okay is equal to, I initially set it to a null value. Then we can go and read the video. So I can show up open file dialog to the user. We call it dialog is equal to new open file dialog. And I just want to read the videos, so I will apply a filter. We need to apply a filter, and so it is just like first we provide the description, so video files, and this description, for example, we can select .avi files, semicolons. This is the description. You can write whatever you want in semicolon, and then we put this pipe, and then we provide the extensions. These extensions are separated by semicolon. If you have more, and then we can put a pipe, and then we can say all files. This will be the description. Star, it means every file that we want to show, and then again the actual extension is basically separated by a pipe. So Well, I just want to select .avi and mp4 files. Of course, you can select any type of video files that you want. So if dialog box dot show dialog, we will show the dialog to the user. And if user selects something, then the result will be okay. So if the user has selected something, then we can check that if we are already displaying a video or not. If my video capture is not equal to null, it means that there is another video going on, user has already played, or video dot is opened. Then we can say video capture dot dispose, and I just for the sake of using the if condition, I will set this one to null. Else, if it is not, not else actually. So if it is null, then we just destroy existing one. If it is not available somehow, we just need to create a very new object with a new video. So create a video by creating an object of new video capture, and this one is expecting. And we can capture from the camera if it is index is 0 or whichever the camera you provide. If we provide a file name, it means that we are going to read from the video. So I want to read from the video, and the path of the video can be selected from dialog.file name. The user must select it. So that will create the video object. But I want to show the first frame in the picture box to the user of this video. So what I will do, I need basically a made object, and let us call it a frame. I will read the first frame and store it in this made object. And to read the frame from this video capture, I will be using the read function of this video capture dot read, and this one will read the frame and put it in my frame object. So once the frame is read into frame object, we can show it in picture box. So picture box dot image is equal to frame dot, we need to convert it into a bitmap to bitmap. So this one will read the video, create the video capture object, and show us first frame in this picture box. So we can go ahead and double click on this detection mask R-CNN video and complete this code for detecting the object from this video for each frame. Okay, so here I will make sure that the video capture object is not null, so that we can further process it. So I'm going to write a condition here. If this one equals to null, we can throw a new exception, and we can mention that please load a video. Okay, and now we can go ahead and load the pre-trained weights, the architecture, as well as the class names. So to make the application more flexible, I can write them the paths here directly, but it's better to use a flexible way. I'm just going to right click on it, go to the add, and I'm going to add a new item, and there is a configuration file. So then over there we can easily write the information or the paths, and we can carry this configuration app.config file to anywhere we want. So inside this configuration file, I'm just going to add some new app settings section, and inside it I'm going to add a new, these are basically the key and the pair value pairs. So I need three things, so I'm just going to copy and paste all of them. In one of them we can put the model path. Remember that I use the capital letters, so the exact same thing we should use the key. And model architecture, let's say, and then last thing Coco classes. So I just need to paste the values into this one. So I'm just going to get this Coco pre-trained model here and paste it right there. The second one is the architecture pop text, so I'm going to put it here, and the Coco name is, of course, we also need to display the name, so I'm just putting them over here. So it is flexible. This file we can change it without changing the code. So I'm going to read these values in the form. So what we can do is, let's say, variable, where is the model path? We can read it using the configuration. Okay, so if it is not showing it up here, what we can do is we have to go and include that here. So system.configurations. So we can write configuration manager dot app settings, and inside the app settings, you remember I created an app settings, and which key that we want to read is we want to pass it as a key. Okay, so I'm just going to copy and paste for the other three models as well. One is the model path, the other is config path, and the last one is the Coco names path, let's say. And we need to write exactly the same model architecture. So second one, I'm going to read the model architecture, and the third one is the Coco classes. Since I need these Coco classes, I should declare them on top. Also, along with this video capture, we can create a string array, string, and this is the array. We can call them Coco classes, for example. And also, I need to declare the cafe model, so we need to create a net object, and we can name it like cafe model, for example, and we can set it to null initially. Then we can load it. So cafe model is equal to DNN invoke dot read from tensor, because we have a tensor model, and this one will expect the model path. So we provided the model path, and we also need to provide the configuration path. So the model will be loaded, and here we also give some other information such as the backend that we want to use, preferable backend .opencv I'm going to use. If you have CUDA, you have to do some other settings as well. And the model is ready, and we can also set here one more thing, that optionally dot set preferred target. Since I'm using the CPU, so I'm going to tell that I'm going to use CPU. And we can also load the Coco classes, and to load them we can use file.read all lines, and we need to pass this Coco names path. So this one will read all the path names. So our model is ready, our labels are ready. We can go ahead and apply on our video. So what I will do is, the video capture object is ready. What I will do is I'm going to add an event so that we will process every frame dot what we call it image grave, and I'm going to create a new event tab, and let us give it a name like process object detection. Okay, and here is our method. So for every frame, whenever the frame is captured, it will call this method. So what we want to do in this method, we will detect objects for every frame, and after capturing we will call it video capture dot start. We can start immediately capturing the object. So for every frame it reads, it will come to this method. So I'm just going to write a prime cage, and I can throw a new object, ex.message. I'm throwing the error from here, and we can catch it here. I will keep reading the images from the video, frames from the video, and we can create a new object to store the frame. So let's call it mate frame, and then we will use the video capture dot read to read from the video and put the result in this frame object. We need to make sure that this frame is not null. If it is equal to null, then what we can do is we just return. If it is not null, it means that we have an image, then we can go ahead and process it. So we need to convert this image into a binary large object so that we can take it as an input to the tensor. So let me first convert it into an frame EmguCV CV image type by using this to image, and we can set it at BGR, and the depth will be the same as the byte original images. So let us convert this one into a blob by calling this dnninvoke.blob from image. And this one is expecting the image, and I'm not going to do any scaling, and the frame size, instead of default, I'm just going to use the frame size dot the original size. So this will affect a little bit, and for sweep RGB I'm going to set it as true so that the blue and the red channels are interchanged, because Emgu CV read them as BGR while the tensor expects them in RGB. So once our blob is ready, we can set the input for our cafe model. So dot set input, and this will be the input for our cafe model. So literally it will do the processing and it will give us the results. So now we need to get the results from this mask R-CNN, and let me create a vector of mate. So new vector of mate object, because we need two outputs. One is the detection rectangles, bounding boxes, and other is the detection masks. So we will create a string to let the model know which outputs actually we need. So I call it that output names. It will be a new string array, and we need to write exactly the same thing. The name of the layer is detection underscore out underscore final, and actually I don't need the masks, so I will just keep this detection underscore out underscore final. So because I want the bounding boxes, and just I want to show those bounding boxes. So we can ask the model to pass this image and give us the outputs. So we use the forward method, and we need to tell this one what actually we need. The output will be stored in the output, and what outputs do you need? So we need to provide the output names. So I only need one layer actually. And now once we have those outputs in our output, I need to process it and then show those results. The first thing that I will do is the output basically will consist of the bounding box information and the score for it, and also for each bounding rectangle there is a mask information is also available. So what I will do is I need to apply a threshold that how confident I am about predicting something. Let's say if the algorithm is 60% sure about an object, then I consider it accept that one object. So let's say we define a threshold of 0.6, and I also need a few things like for example, how many detections are there. So we can get number of detections from output. The output there will be 0th one dot size of dimensions, and this is the second one, index second. So this one will give us how many detections have been done, and also how many classes are there. We can get it. And we also know that number of classes it is on Coco, so this will be 90. And we can now read all those bounding boxes. Let's say b boxes is equal to output 0. And for making it easily loop through the data, I convert it into a C# or .NET Framework array. So this b box is an array now, you can see. And we can go ahead and loop through this array and try to display those bounding boxes. So for I integer is equal to 0 to number of detections, and for each detection we will see the scores. So I will calculate the score is equal to b boxes dot get value, and the scores will be for ith detection, and the scores are present in the third, that is the index number 2. And of course this will be a float. I need to cast it into a float, and I can apply a threshold on it. If the score is greater than our defined threshold, then we can display that. So the first thing, which class is this? Okay, we have the score, so the predicted class that we receive is integer, let's say class ID, and we can apply convert dot integer 32 b boxes dot get value 0 0 for the ith bounding box, and it starts from the third index. It basically present on the first index. Okay, so this one will be the class ID, and then I need to calculate the left, top, right, and the bottom points of the rectangle to display them. So let's say that left is equal to, we can also use the convert dot to in 32 v boxes dot get value, and this one will start from, for the ith rectangle, at the third location. And we also need to scale it to match with our image so that we can fit it into the image. So I multiply it with the columns, and yes, so we need to convert this object into a float, so I call it float. Okay, so this one we get the left of the rectangle for the top, and for the right and the bottom. So this one will be the top, this one will be the right, and this one will be the bottom. Okay, also need to change here. So the fourth, the fifth, and the sixth, and also this one should be the rows, because it is, and also multiply with the rows. Okay, so we scale it back into the original scale, and then we can display it. And to draw it, we can use, first we create the rectangle. Let me create the rectangle, RECT rectangle, new rectangle, and here you can see we can provide x, y, width, and the height. So left will be the x, top will be the y, and when I do right, minus left plus 1, this one for the width, and for the top and the height, bottom minus top plus 1. Okay, so once the rectangle is ready, then I can draw that rectangle using this draw function. So I'm draw box rectangle, and then the color that we would like to draw is let's say a rectangle. So this is the color, and the thickness I just want to make it 2. And one more thing, if we want to show the labels, so let us read the label present on that class ID, and we have already those Coco classes, and using that class ID we can read whatever the class name is, and we want to display it. So cv invoke dot put text img and a label, and we can create a new where we want to display it. So we can say that along with the left and the top -10. So just I move it a little bit in the upward direction, and the font face that we like to use, let's say we use the simplex. If you want to use the scaling, I just keep it as it is, and of course we will give a color for our text. So 0 to 5,0. Let me push it to the next line. Okay, and last we can give a thickness of 2. That's it. So we put the text also, and the label, and then we can actually outside of this loop, so we can display. So outside of this loop we can display in the picture box, but remember that you cannot directly display picture box dot image is equal to img dot to bit name. The reason is that this one will give you error when you are using this event, because this one will run on a different thread, so you cannot update your main thread, that is Windows Forms, from another thread. So what could be the solution is I will be using basically the picture box anonymous method, which we call it the invoke. So what I will do, picture box dot invoke. This method is basically expecting a delegate. So I'm just going to create a delegate, and inside it we can basically update it. So what it will go do is it will go to the UI and update the picture box, and then come back to the thread again. So here I need to cast it into a method invoker. So this is what actually you need to do. The idea is just go to the main thread, update my picture box, and come back and continue reading the next frame, and so on and so forth. And that's it. Let us see if it runs successfully or not. So let us try a demo. First thing I will do is go and read a video. You can see that only 2 types of videos are supported, and let's say the walking video. So you can see the first frame is displayed, and then we can go and apply the object detection from the videos. So this one is taking a time, but for example for the first frame, the second, and so on and so forth, it is continuing to detect. It detected the cars, the truck, the person, and I think it is wrong. It says it's kite, it is not, but the persons have been detected. And one more thing that you also notice, that this output is basically on CPU. So if you want to do a real time, then your hardware should be faster, and also if you use the CUDA or the GPUs, it might become near real time. But somehow it takes about 2 to 3 seconds, I guess, over here. But it detected the persons. So this is how we can apply on our videos. Let's say I'm not interested in kite or the trucks or any other thing. I only want to interest the persons. So you can only apply a condition, for example. We already know this class label. In fact, we can do one thing here. If, for example, I'm interested in only person detection. There are 90 classes. I'm not interested in all of them. What I will do, you need to check that the person's class is basically the first one. So its ID is 0. So the IDs are already given here. So if I am interested in the person class, what I will do, if the class ID is not equal to 0, then continue. So the loop will continue, and if it is not a class, if it is person, then we should continue. If it is not, then it will just jump to the loop. It will not go down there, and it should not show us. So let us go, and we want to detect specific person object only. So I'm going to read the image and the video again, and then apply the object detection. Now you can see it is not detecting. I just applied the condition over there. And other flexibilities that you can play, any object that you want to play, you can change that condition. Or for example, you can also increase the threshold. That if there is a person, I want to make sure that it is 80% sure. So the threshold should be minimum 80. So let's go ahead and select that one again, and we want to detect that. So now you can see that it is detecting the person. Or if you want to detect from another video, for example, anything that you want, I just want to comment this line, and I just want to make this one to 60 again to be make sure I'm getting more objects. So I will try on another video file, open, and there is a cars video, and then if I apply object detection, so you can see it has detected some of the cars. Of course, some it is missing, some of them maybe the image is quite low resolution or maybe very small, but at least if you are interested in detecting the cars which are near here somewhere, so it is detecting in some cases, in some frames, and in some cases maybe they are too far, it is unable to detect them, but you can see it is detecting them when it is near to here. Okay, so that is how you can adopt the Mask R-CNN object detection on your videos. Okay, let's see you in another video.